In this lecture, we discuss about the partial differentiation of a function which depends on the more than one independent variable. Find first and second order partial derivatives of the functions u is equal to x cube plus y cube plus x square y plus xy square plus xy plus 2. We have to find the first and second order partial derivatives of the following function. U is equal to x cube plus y cube plus x square y plus xy square plus xy plus 2. Let us give it equation number 1. Now, what is the meaning of partial derivatives? Now here, u is a function of x and x and y are independent variables. So, if any function like u is depending upon two independent variable or more than two independent variable, at that time it is not possible to find out the total derivative. Total derivative of a function can be obtained only when the function is depending upon only one independent variable. So in this case, we want to find out the partial derivative. We want to find out the derivative of u with respect to x and y. Since we are not able to get the total derivative in this case because we don't know what is the because x and y both are independent. So if you want to find out the derivative of x, u with respect to x, derivative of u with respect to y, both will be independent to each other. Now, if you want to find out the partial derivative of u with respect to x, we consider y is constant. And if you want to find out the partial derivative of u with respect to y, we consider x is constant. So let us try to find out the partial derivative of u with respect to x as y. Differentiating one partially with respect to x and y respectively, we have del u del x. So now, instead of writing d dx, partial derivative is represented by del x. Now, let us put the value of u. U is nothing but x cube plus y cube plus x square y plus xy square plus xy plus 2. Let us try to do the separation. We have to open the bracket. So partial derivative of x cube with respect to x, partial derivative of y cube with respect to x, partial derivative of x square y with respect to x, partial derivative of xy square with respect to x, partial derivative of xy with respect to x, and partial derivative of 2 with respect to x. Now, since we know that if you want to find out the partial derivative of x with respect to y, this should be constant, this y should be constant, this y square should be constant, and this y is also constant. It is already constant. 2 is already constant. So let us do accordingly. We cannot write, we can write down this as it is. We have taken y cube outside. So partial derivative of 1 with respect to x. Here we have taken y outside. Partial derivative of x square. Here we have taken y square outside. So partial derivative of x is remaining. And if we take y outside, it is partial derivative of x. And we have written this as it is, partial derivative of 2 with respect to x. Now, what is the derivative of x cube? So derivative of x cube is nothing but 3x square. Derivative of 1 with respect to x is 0. Derivative of x square is 2x. Derivative of x is 1. Derivative of x is 1. And derivative of 2 is 0. Let us simplify this. 3x square, y cube into 0 is 0. This y into 2x is 2xy plus y square plus y plus 0. So 3x square plus 2xy plus y square plus y. This is the partial derivative of u with respect to x. This is represented by p and its value is 3x square plus 2xy plus y square plus y. This is the partial derivative of u with respect to x. Let us try to find out the partial derivative of u with respect to y. del u del y, this can be written as partial derivative of y with respect to u. U is nothing but x cube plus y cube plus x square y plus xy square plus xy plus 2. So we can again write down separately partial derivative of x cube with respect to y, partial derivative of y cube with respect to y, partial derivative of x square y with respect to y, partial derivative of xy square with respect to y, partial derivative of xy with respect to y, and partial derivative of 2 with respect to y. Now, here, since we want to find out the partial derivative of x cube with respect to y, so we consider x is independent, or this is a constant, so we can take outside x cube, partial derivative of 1. This can be written as it is. Here we can take x square outside. Here we can take x outside. Here we can take again x outside. And 2 is, we can write down 2 as it is. Now, what is the partial derivative of y 1 with respect to y? Constant, it is 0. So this part becomes 0. Partial derivative of y cube is 3y square. Partial derivative of y is 1. Partial derivative of y square is 2y. And partial derivative of y with respect to y is 1. And the partial derivative of 2 with respect to y is 0. If we simplify it, this becomes 0. 3y square plus x square plus 2xy plus x. So the partial derivative of u with respect to y, which is represented by q and is given by 3y square plus x square plus 2xy plus x for this function. This del u del x and del u del y is called first order partial derivative. Why? Because we have differentiated u partially with respect to x and y only one time. So if you want to find out the second order partial differentiation or derivatives, we have to again differentiate del u del x with respect to x and y, and similarly del u del y with respect to x and y. So now here we are finding the partial derivative of del u del x with respect to x. It can be written as del 2u del x square. And since what is the value of del u del x? It is 3x square plus 2xy plus y square plus y. So let us put in the same manner. And again, if we write down, if we open the brackets, we can write down the partial derivatives of different terms as it in this manner. Again, partial derivative of 3 we can take outside. We can write down x square. Here 2y we can take outside. Partial derivative of x. Y square we can take outside. Partial derivative of 1. And partial derivative of, we can take again y outside. Partial derivative of 1. So partial derivative of 1. Partial derivative of 1 with respect to x will become 0. And now this is partial derivative of x square is 2x. Partial derivative of x is 1. And this 2 term will become 0. So we have 3 into 2x is 6x plus 2y. This is the partial derivative of u with respect to x square, or we can say that the second order partial derivative of u with respect to x square. This is represented by r, and whose value is 6x plus 2y in this example. Let us again differentiate this del u del x with respect to y. So we can write down del 2u del y del x. Now what is the value of del u del x? It is 3x square plus 2xy plus y square plus y. If we differentiate this with respect to y, we can write down partial derivative of 3x square with respect to y, partial derivative of 2xy with respect to y, partial derivative of y square with respect to y, and partial derivative of y with respect to y. If we again do the partial differentiation, the 3x square can be taken outside because it is constant with respect to y, so only 1 is remaining. Here we can take 2x outside, y is remaining over here. The partial derivative of y square with respect to y is 2y. Partial derivative of y with respect to y is 1. Now partial derivative of 1, it will give 0. So 3x square into 0 plus 2x, partial derivative of y is 1, plus 2y plus 1. If we simplify it, this becomes 0. This is 2x plus 2y plus 1. So this is the partial derivative of second order partial derivative of u with respect to y and x, and it gives us 2x plus 2y plus 1 in this example. So this is what it is, the second order partial derivative of u with respect to x and with respect to y and x. So let us again do the partial differentiation of del u del y with respect to x and with respect to y. Now, what is del u del y? Del u del y is nothing but 3y square plus x square plus 2xy plus x. So if you want to find out its derivative with respect to x, we have to first separate all the terms. Now 3y square is constant with respect to x, so we can take outside. Similarly, partial derivative of x square with respect to x is 2x. Now we can take 2y outside, so x is remaining. Partial derivative of x is equal to 1. Here 3y square partial derivative of 1 with respect to x is 0, plus 2x plus 2y partial derivative of x with respect to x is 1 plus 1. If you simplify it, the first term is 0. So 2x plus 2y plus 1. This is what? It is the value of, it is s again. It is the partial derivative of u with respect to x and y. And it gives us 2x plus 2y plus 1 in this example. Similarly, let us try to find out the partial derivative of del u del y with respect to y. It is written as del 2u del y square. And we know that del u del y is nothing but 3y square plus, now it is clear, 3y square plus x square plus 2xy plus 1. So which gives us again partial derivative of 3y square, partial derivative of x square, partial derivative of 2xy plus partial derivative of x, all with respect to y. So now this is what? 3y square, 3 should constant, partial derivative of y square, x square we can take outside, partial derivative of 1. Here we can take 2x outside, partial derivative of y, and we can take x outside, partial derivative of 1. What is the partial derivative of y square with respect to y? It is nothing but 2y. Partial derivative of 1 with respect to y is 0. Partial derivative of y with respect to y is 1, and partial derivative of 1 with respect to y is 0. Now this is 6x, this is 0, plus 2x, and this is 0. So we have 6y plus 2x. So this is the value of del 2u del y square, and this is represented by t, and whose value is 6y plus 2y in this example. So now let me just summarize it, what we have done in this example number 1. We have given the function x cube plus y cube plus x square y plus xy square plus xy plus 2. If you want to find out its first order partial derivative with respect to x, then this is 3x square, this becomes 0. So now we have 3x square, this is 0. Derivative of x square is 2x and 2xy. Here derivative of x is 1, so we have only y square. Derivative of x is 1, so we have only y. So this is what it is, a partial derivative of u with respect to x. Similarly, partial derivative of u with respect to y, this is 0. Derivative of y cube is 3y square. This is x square. This is 2xy. And this is x. And this will become 0. So this is a partial derivative of u with respect to y. If we take the second order partial derivative, so now again differentiating this with respect to x. So now this is nothing but 6x. And this is plus 2y. This 2 will be 0 because these are the function of y only. So we have 6x plus 2y. Similarly, if you want to find out s means partial derivative of u with respect to y and x. So let us again partially differentiating this with respect to y. So this will become 0. This is 2x plus 2y plus 1. This is what it is, a partial derivative of second order partial derivative of u with respect to y and x. Similarly, if we do this same thing, but we will first find out del u del y, and if we differentiate this with respect to x, so this is 0, derivative of x square is 2x, derivative of 2xy, so 2y, and derivative of x is 1. So this is what? So now just look here, del 2u del y del x and del 2u del x del y both have the same value. Both have the same value. And the last one, t is equal to second order partial derivative of u with respect to y, which is given as u y y, and it can be, now we have to just differentiate this with respect to y. So the 3y square derivative of this is 3 into 2y is 6y. This is 6y. Derivative of x square with respect to y is 0. This is also 0. And here this derivative of y is 1. So we have just 2x. So these are the first two are the partial derivative of u with respect to x and y of order 1, and the remaining 4, actually it is remaining 3 because these two are same over here. So these 3 are called second order partial derivative of u with respect to x and y. Thank you.